EES, which is pronounced EASE, is an acronym for Engineering Equation Solver. In the last few videos, we've talked about using property functions in EASE. The values of specific internal energy, specific enthalpy, and specific entropy that are returned by these functions are not absolute. They're only defined relative to some reference state. In most problems, the reference state doesn't matter, as we're only interested in the change in these specific properties as a pure substance or a fixed composition mixture changes from one state to another. If chemical reactions occur, then the choice of the reference state does become important. The specification of different reference states is the primary reason that various sources of property information may appear to be providing very different property values. There are several common reference state choices that you can choose. These are shown here. You can see the International Institute of Refrigeration reference state, which is indicated by IIR. The IIR reference state sets the value of specific enthalpy to be 200 kilojoules per kilogram and specific entropy to be 1 kilojoule per kilogram Kelvin for saturated liquid at 0 degrees Celsius. And therefore, the IIR reference state can't be used for fluids where the critical temperature is less than 0 degrees Celsius, because for those fluids there is never saturated liquid at 0 degrees Celsius. The ASHRAE standard reference state is indicated by ASH. The ASH reference state sets the value of specific enthalpy and specific entropy equal to 0 for saturated liquid at negative 40 degrees Celsius. And again, the ASH reference state therefore can't be used for fluids where the critical temperature is less than minus 40 degrees Celsius. And then there's the normal boiling point reference state, which is indicated by NBP. The NBP reference state sets the values of specific enthalpy and specific entropy equal to 0 for saturated liquid at the normal boiling point, so the saturation temperature at 1 atmosphere. And therefore, the normal boiling point option isn't applicable to fluids for which the critical pressure is less than 1 atmosphere. The default reference state for each fluid in EASE is specified in the online help property information for that fluid. So you can see, for example, that shown here. The dollar reference directive allows the reference state to be changed from its default setting to any of those discussed above, IIR, ASH, or MBP. And the format of this directive is shown here. Fluid name refers to the name of a real fluid or a string variable, so for example maybe our $sign that has been assigned to the name of the real fluid. And then reference ID must be either IIR, ASH, or MBP. Or you can use DFT, which indicates that you want to use the default reference state. If the reference state choice is not applicable to the fluid, then the reference state will remain at its default value. Note that the dollar reference directive is not applicable to fluids that are being modeled using the ideal gas equation of state. Most of the EASE real fluid properties are modeled using the fundamental equation of state as the basis for the property relations. This is the most accurate method available. However, there are a few fluids in the EASE database that are represented more approximately using the Martin-Howe equation of state, and these are indicated in this table. The Martin-Howe equation of state will provide accurate property information in the saturated and in the superheated regimes, but in the subcooled regime it's going to assume that liquids are completely incompressible. It's actually possible for users to add real fluid property information to EASE based on the Martin-Howe equation of state as described in section 4.10 of Mastering EASE. But the dollar reference directive is also not applicable to any of these fluids that are being modeled using the Martin-Howe equation of state. So as a quick example, let's look at the refrigerant R134A. Now, by default, the reference state for this refrigerant is set to the ASHRAE standard. So the specific enthalpy at 320 Kelvin and 420 kilopascal is calculated here to be 290 kilojoules per kilogram. And this should really be interpreted as being 290 kilojoules per kilogram higher than the value of the specific enthalpy of saturated liquid at minus 40 degrees Celsius, where the ASHRAE standard reference defines enthalpy to be 0. And you can see that here. So the change of enthalpy between these two states is 290 kilojoules per kilogram, delta H. So if I put the dollar reference directive at the top of the equations window, I can change the reference state for the R134A fluid from the ASHRAE standard to the IIR standard, and that's what I'm doing here. And if I solve now, you'll see that the absolute value of the enthalpy at 320 Kelvin and 420 kilopascal has changed a lot due to the definition of this new reference state. But you should also note that the change in the enthalpy that I computed hasn't changed at all, because the reference state has no impact on changes in enthalpy, or for that matter entropy or specific internal energy. So this is one of a series of tutorials meant to describe the operation of the EASE software. If you'd like to get more information about EASE, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering EASE, which can also be obtained from the FChart website.